right, guys. All right, so the plan originally today was to start a new topic because this is really like almost like the second class. I just felt it prudent for us to just do some work to build confidence in the subject. And so because the worksheet that we did last week was just a worksheet, I said, let me bring some actual past papers for you and show you how the questions are set on the actual past papers. All right? And work them through and so on. And so you can see that this add maths and pure maths business is nothing like rocket science. It's really simple stuff. Understand? Nothing difficult, believe me. All right, so the topic is polynomials. And the main area of polynomials is the factor theorem and the remainder theorem. The use of the factor theorem and the remainder theorem to solve equations and do other stuff. So this question, this paper on the screen right now is actually the CAPE. I know this class has ADMAT students in here now. And this is a CAPE paper. See, CAPE Pure Maths Unit 1. All right. So I'm showing you that this topic is a topic that is common to ADMATs and pure maths. So imagine if you are doing ADMATs, I can actually do the pure maths level 1. They're good to go. All right. So it shows how easy ADMATs is really. All right. So this question here is similar to one that we did the other day in the classroom. It gives us this polynomial expression or this polynomial function. It tells us that it is divisible by x minus 1. If it is divisible by x minus 1, it means that the x minus 1 is a factor. And if it's a factor, that means that f of 1 is equal to 0. But understand that. Based on the factor theorem and the remainder theorem. If x minus 1 is a factor, f of 1 equals 0. If x minus a is a factor, then f of a equals 0. That's a factor theorem. All right? And then it says it has a remainder of -6 when divided by x plus 1. So the remainder from x plus 1 is -6. So I write it like this. The remainder from x plus 1 is -6. The remainder from a divisor of x plus 1 becomes f of -1. But I can appreciate that. F of -1. To know it's f of -1, one way to do it is to put x plus 1 equals 0 and get x equals -1. They're looking for f of -1. But if you go from the theory aspect of it, remember your divisor must be in the form k into x minus a. And the x minus a really is a critical expression in your divisor. So if you have x plus 1 and you want it to look like x minus a, then this plus inside here, we can change it to a minus, it becomes x minus a -1. And so this is your a. And that's why f of -1 becomes the remainder. And in this case, the remainder is -6. That's what the question said. So what's going to happen? And these questions are typical, right? What's going to happen is that for this one, as we said, we're going to write, let's put it here. We're going to put it here, that the f of -1 is equal to -6. And then we have this one. So those two are going to produce two equations for us. And because there are two unknowns, we're going to solve those two equations simultaneously to find the two unknowns. This is on a pure maths exam paper now. And you can get a similar question, almost exactly like this on an ADMAS paper. Let's see if I can find one and show you right after this one. All right? But typically, that's how these questions are. Two unknowns, they give you two pieces of information. Oftentimes, they give you one factor and also give you a divisor with a remainder. As I said, they set up one equation with this and set up another equation with that. And they solve the two equations simultaneously. That is it. So let's do this one. F of -1 equals 6. Equals -6, right? The remainder is -6 when the divisor is x plus 1. Let me write it out here. This is saying the remainder from x plus 1 is equal to -6. And that's what we get this. And this one was a factor. So f of 1 is 0. So basically, we're going to put -1 in this function for the x. And the result is -6. Simple as that. So we're going to end up with, right here, put -1 cubed becomes a -1. 2 times -1 is -2. So this expression becoming a -2. Then this x squared here is -1 squared. -1 squared becomes 1. So it's like 1 times -p is -p. So it becomes a -p. Then if we put -1 here for this x, the -1 times this q give me -q. And then I have this -10. And that's all equal to -6. We're going to simplify this now. This and this is -12. -12 comes on this side to become a +12. +12 minus 6 give me 6. So the right side is going to become a +6. I'm going to have minus p minus q. Minus p minus q equals 6. Everybody go to that? But okay with that? That's one equation. We're going to get the other equation from this one now. F of 1 is 0. So we're going to plug the 1 inside here for the x. And then equate that result to 0. So we'll put the 1 inside here. It becomes 2. Put the 1 inside here for the x squared. 1 squared is 1. So we get -p. Put 1 inside here. We get q times 1 is q. And then this is -10. And that's all equal to 0. Because that's a factor. This reduces to, this is 2 minus 10 is -8. -8 will come on the right side as a +8. So we end up with -p plus q equals, what did we say? A +8. And so we're now basically solving these two equations simultaneously. This one, which we can call equation 1, and this one, which we can call equation 2. That's the problem. And if we just add these two equations, if we just add the two equations, we will eliminate the q. If we add them. So it's going to add them. 1 plus 2. Equation 1 plus equation 2. So we have minus p and minus p gives us -2p. This minus q plus q becomes 0. It's eliminated. Equals this 6 and this 8 on the right side is 14. Then we divide by the -2, we get p equals -7. That's the value of p. Now that p is -7, we can take it and substitute the -7 in this one, where the p is. So we can say and. We can say and. Or we're substituting it in this one now. No. Minus -7, because the p is -7. Plus q is equal to 8. This minus becomes a +7. 7 subtract over here gives me 1. So q equals 1. Q equals 1. And that is it. That is it. And that's on a pure maths paper. We're getting the same thing that you will see on AdMaths. All right? That is it. So the person just coming in. So Patriana, they just decided that we wanted to just practice some more on this topic. All right. So you guys are gonna have to give me back Sunday. So we're gonna have Friday's class on Tuesday, Tuesday's class on Friday, and Friday's class on Sunday, something like that. All right. So we're gonna have to add back a day Sunday. Come in. Yeah, AdMaths stuff. Because we're gonna start the pure math Sunday. I haven't started the pure math Sunday yet. I haven't started the pure math Sunday yet. All right? Good. So that is the plan. Because the next topic that we're going on is surge, logs, and indices. That's what our plan. My plan was for today, but first said I want to just have another look at this topic. All right? That is it. Any questions on this? Pretty straightforward, right? And that is it. I think that is the end of that question. So what you'll find, all the exam paper set up, right? Like look at question 1 now on this pure maths paper. For those of you who don't know. This is actually question 2. So part A of it, part A is one question from one topic. Part B is another question from another topic. Part C is another question from another. So you might have 4 parts or 5 parts in a question. And it's actually 5 different topics in the one question. That's how the ADMAS is set up as well. You get me? So you can see part A is a functions of question 2. All right? Part B, that's a surge, logs, and indices. That's a disguised quadratic equation. That's a disguised quadratic equation. It has the indices question. That's part B. Part C is this polynomials question. A whole question by itself. Part D is a sum and product of roots. It's a topic we're going to do later. So we're doing this topic for ADMAS, but we're only doing it for quadratic with 2 roots. We're doing this topic for pure maths, which is basically the same thing you're doing as you would do with ADMAS, just that you're using 2 roots. In ADMAS, using 3 roots in pure maths, 2 roots in 3 roots in pure maths, 2 roots in ADMAS. But the things that you do with the roots are the same. All right, the process is the same. So that's four sections, 4 different questions. That's 2022. All right, I want us to look at the ADMAS paper now. So that was the pure maths paper, and you see. So this will basically explain why it is that I can have the 2 of you in the same class for these topics. So let's look at ADMAS now. Let me find the ADMAS paper 2. All right, this is 2024. Exam just gone the other day. 2024. Let me see if there's any polynomial on it. It's 2024. The paper just gone the other day. See it here? That's a polynomial right there. First question. It said determine the other linear factors of this polynomial. Determine the other linear factors of this polynomial, given that x minus 2 is a factor. Determine the other linear factors of this polynomial, given that this is a factor. All right, so how many more linear are you supposed to get? 2 more, because the cubic will have 3 linear. The cubic will have 3 linear, or it will have 1 quadratic and a linear. So how are we going to find the other factors? Huh? How are we going to proceed to find the other factors of this, given that this is a factor? What would you do? Trial and error? You're not solving anything, my boss. You already have a factor, you have to try now. You already have 1. Come on, man, no matter what to say. How would you find the other factors? Divide it out. Divide it out. Remember, if you have this quadratic, if you have this cubic, I divide it by this linear, it's going to equal to a quadratic. And you can factorize a quadratic normally. And that's where you find the other 2 factors. So you have to divide the cubic by the linear. Get me? All right, let me do this one for you. I'll do this one. We're going to do some questions today, because we're coming off this topic. And that topic worth mastering. You get me? That topic worth mastering. So all we have to do is divide it. Just divide it, right? So we're going to divide by the linear factor. That's all we have to do. Divide. So we can do the long division. X minus 2. And it is 3x cubed plus 8x squared minus 20x minus 16. So this is the advanced paper just set in June. Gone, right? Just the other day. This is it. So it is 3x cubed divided by x. Give me 3x squared. Then it's 3x squared times these. Give them back the 3x cubed. And minus 6x squared. And remember, you subtract it. And then these now, I'm going to work it out now. So remember, these two values are always eliminated. And you apply this minus on this to see what it becomes. It becomes a positive 6x squared. Positive 6x squared plus 8x squared give me 14x squared. So I'm getting 14x squared. And then these not subtracted anything, and so they come back down. So I'm getting minus 20x minus 16. Then again, it's this first value divided by this first value. So I'm getting plus 14x. There's 14x times these, giving me 14x squared minus 28x. Subtract. Again, the first two values are eliminated. Then this minus give you a plus. So it's 28 minus 20 give you 8. So you're getting 8x minus 16. That's 8x divided by the x right here gives me 8. Then it's 8 times these will give you now the 8x minus 16. And we subtract this now, you're getting a remainder of 0 because this was a factor. And then what you can do here is just factorize this right where it is. And I'm going to just factorize it right up there. Because that's a quadratic factor now that has the two factors in it. You see, this expression now is a product of these two. This original expression is product of those two. The divisor and the quotient. All right? So to get the other two factors, I just need to factorize this quotient. You can factorize it right where it is, like this. Factor of this has to be 3x and x. You want factors of 8, such that the far product and the near product give me 14. So I'm going to put 4 here and 2 here. So my far product is going to be 12, near product is going to be 2. 12 and 2 is 14. So they are positioned the right way. And everything is positive. See, everything is positive. So it's easy. So it's plus, plus. These are my answers, you know. The answers for the other two factors. So these are actually my answers. These in red are my answers. The other two factors. That's it. Those are the answers for that. All right. And then here now it says, hence, simplify this thing. Hence, simplify this thing. So what it is that this numerator is a product of these three factors, these and these two. So kind of write the factors up there. All right. And then now you realize that this down here is the difference of 2 squares. What are the factors again on this numerator? So we can say this implies this numerator becomes, the first factor was x minus 2. Then what do we get again? We get 3x plus 2 and x plus 4. 3x plus 2, x plus 4. 3x plus 2, x plus 4. This denominator becomes the difference of 2 squares. So it is equal to x minus 4 times x plus 4. They will multiply that result with this, which is x plus 2 over x plus 4. All right, so we're going to cancel some terms now because we're multiplying. Let's cancel some terms. So this x plus 4 cancels, but wait. That x plus 4 cancels this x plus 4. Right? And then this becomes the difference of 2 squares again. So I didn't have to do, I could have left these two. What's the purpose of these? 2 are the difference of 2 squares, these two. And these two come back as the difference of 2 squares. Why is that? Simplify. I'm not seeing what will cancel. I'm not seeing what will cancel. These two are the difference of 2 squares. So I'm getting back x squared minus 4 from these two. Let me underline them in blue. This and this. Give him back that, yes? Oh, all right, thanks. My mistake. Right. So this is supposed to be 2 and 2. All right, beautiful. That is where it is. All right. That's why I wasn't seeing it. Wasn't making sense. All right, my mistake. All right, x plus 4. So this is 2 and 2, right? All right, good. All right, now it makes sense. So what will happen now is that this x minus 2 cancels this x minus 2. This x plus 2 cancels this x plus 2. This x plus 4 cancels this x plus 4. And we are left with just this. 3x plus 2. All right, thanks for that. So this is now equal to 3x plus 2. That's it. All right, and I think that finishes that question. This is a different topic. Same alpha and beta thing. That is it. All right, so you see, you must start to gain confidence now. Because seeing that these things are really simple, right? This is 2024. All right. So I'm gonna bring back another pure maths paper now. Right, mom, over there? Yeah. Let me bring back another pure maths paper right now. Can I take this off? Can I take it off? I remember they are recorded, right? So I'm recording so you can watch it back later. I'll share it. All right, let me bring back another pure maths paper now. Let's go back for a pure maths and see. See if we find any with a little sugar on it. Let's see. Pure maths. Paper 2. Unless you got 2021. And I'll give you a minute to do it. I'll give you a minute to try it. So you see, you're doing odd maths and you're already doing pure maths questions. So it means that all of you should really run into to do odd maths next year. See there, almost the same thing. Look at that. Same thing. It says this polynomial expression, again, there are two unknowns, A and B. This is pure maths now. It is divisible by this. That means that that's a factor. And as a remainder of -5 when divided by this one. So remember, this information is going to give you one equation. And the fact that this is a factor going to give you another equation. And they solve the two equations simultaneously to find the A and the B. Typical. So your turn. Let me pause and give you a minute to do it. And see what you have. Put up the clock. All right, I'm giving you. You don't need more than 5 minutes to do this. 5 minutes. Five minutes. You don't need more than 5 minutes. you see clearly? Yeah? This is ax cubed plus 3x squared minus b. That's your f of x. Factor right here is 2x minus 1. That's a negative 5. Remainder when the divisor is x plus 2. All right? A negative 5 over here. Try that later. That's the f of x. Ax cubed 3x squared minus b. 3 minutes, almost 3 minutes. Good. 1 minute. Twenty seconds. You done? Finish? All right, let me do this one. I'll give you another one to do after this. So let me do this one. I'll give you another one to do after this. Ready? So if this is a factor, guys, what is the A? 2 minus, what is the A in this expression? To find the A, a quick way to find the A is to put it equals 0. I make x is subject, x equals half. But theoretically, what you do is factorize away the 2, because you want the divisor to be in the form k into x minus a. You have to factorize this 2. So you factorize away the 2, you become 2 bracket x minus half. And so the half right here will be an a. It's thing. So that f of a half is equal to 0. That's one equation. F of a half is equal to 0. All right? I'm going to put the half in this thing and equate to 0. Half raised to the power 3 becomes 1 over 8 times the 8. Then put the half here, becomes a quarter. A half squared is a quarter. 3 times a quarter is 3 over 4. Minus the b, this is all equal to 0. Now I'm going to break into all those fractions. So I'm going to multiply 2 by 8. Multiply 2 by 8. And this becomes a. This becomes 6. Because 8 divided by 4 is 2. 2 times 3 is 6. This becomes 8b equals 0. So that is one equation right here. Then now the remainder is negative 5 when the divisor is x plus 2. So that means the remainder from x plus 2 is negative 5. It means that f of negative 2 is negative 5. That's going to give my second equation right here. I'm going to plug the negative 2 in here now. The negative 2 cubed is negative 8. So I'm going to get in first negative 8a. The negative 2 squared right here becomes a positive 4. 4 times 3 is 12. This is minus b again. And that is now equal to this negative 5. We'll put 0 now, negative 5. So I'm solving these two equations simultaneously. This, for example, has a 8b in it. This is just a b. Or this is a 8a in it, where this is just a a. So what I'll do, I'll change this one to a 8b and then subtract the two equations. Well, let's transpose this first. Make it negative 17. So I'm getting minus 8a minus b equals negative 17. Make everything positive. 8a plus b equals 17. Then I can multiply by 8. Right? To get this to be 8. Just like that. Multiply this one by 8. I'm solving those two equations simultaneously. Put this one in a box. No, let me just do it first. It becomes 64a, right? This is supposed to be a plus, right? Plus 8b equals, this times 8 is how much? 80 plus what? 8 times 7 is how much? Huh? 96 and all? 96? Sure? Yeah, that's all right. 136. So I'm now solving these two equations. The BS need to add the two equations now. Add them. So if I add 1 and 2, then this and this is 65a. Then the 6 is added alone on this side, so 65a plus 6. Then the minus 8b and the 8b cancel each other. Then the 0 and the 136 is equals 136. I don't like these numbers. I'm going to take this away. Oh, it's okay. Subtract that, I get 130. So 65a equals 130. So a equals 2, right? And if a equals 2, we can substitute the 2 for a right here. For the a. So we can say and substituting this one. 8 times 2 plus b is equal to 17. A2 is 16, you know. 16 subtract over here to give a 1. So the b equals 1. So those are my two answers. This value is an answer. And this value also is an answer. That is it. That's a keep exam paper now. Keep 7 marks I give for that, you know. Oh, that's 7 marks. This is like a baby question and a keep paper. Unit 1. Alright? So y'all get the drift. This is really easy stuff. I tell you. It's easy stuff. This is the topic that we're doing next. Logs. Third logs and indices. But that is it, guys. Very good. All right, bring up our advanced. Bring up our advanced one again. Huh? All right, let's bring up another advanced one again. Let's bring up our advanced one again. Let's go. So basically clearing this topic, you know. After today, we're done with this topic, you know. Next time we see this topic is just revision, right? Only revision. I think that 2023. We're working our way down. 2023. Sometimes the polynomial question ridiculously easy to do on advance. Ridiculously easy. Let's see what I want this one. This is 2023. This one is that this guy's quadratic equation. They are simple with the polynomial there. Come on, I don't need more than 5 minutes to do it. They said that this thing is a factor. That's a factor of this. There's only one unknown in it, is B. And I want to find the value of B. Come on, this is too easy. And they give it 3 minutes to do this. Anything else? And I say ends factorize it completely. Ends factorize it completely. Huh? Huh? Yeah, man, I'll go back. I'll look at this next. So what you're gonna do for me? You're gonna find the B. They tell you that this thing is a factor, right? Because I said this is a factor of this expression. Find the value of B, and then you're gonna factorize it fully after you find the value of B. So let me bring up the clock. You don't need more than 5 minutes to do this again. 5 minutes. You can make the clock float. Huh? Hold on, I'm gonna try to maximize this. Start the clock on it. 5 minutes. Remember now, you're gonna find a value of B, then you're gonna factorize it fully. I need maybe a little more than 5 minutes. Let me give you maybe 8 minutes. 8 minutes. Find a value of B because 3x plus 2 is a factor. And then after I do that, you factorize it fully. Yeah, after I find the B, factorize it fully. After I find the B, you have to factorize it fully. That's what the next part said. See down here, so. So see there? Hence, factorize it. Factorize completely. So do that for me. That description goes down. Four minutes. Youngster, you know how to do work? Huh? You can do it? You can do the work? Yeah, you matter. Huh? You can do it already? Huh? All right. Problem. I'll find out. I'm not going to no good. All right. I'll find out. Since I'm not going to no good. I'm going to real test. Simple question. I'll find out if you're not really good. All right. You guys are get finished, right? All right. Richard, you finished? Oh, all right. I'm going to work it out now. Let's go. All right. So basically, if this is a factor of that, what's the A in this? What's the A in that? Minus 2 over 3. Minus 2 over 3. If I can factorize away the 3, or just put it equals 0 to find the A. You put 3x plus 2 equals 0, x equal minus 2 over 3. This is the A. So f of 2 over 3, f of negative 2/3 equals 0, right? Based on this information, f of negative 2/3 equals 0. F of negative 2 over 3 is equal to 0. Therefore, if we put negative 2/3 over this, it's going to become a negative still. So we're going to get 3 bracket negative 8 over 27. We put negative 2/3 here, it's going to become 4 over 9. So we're going to get plus b times 4 over 9. If we put negative 3/3 here, this becomes a negative 2/3. The negative give me a positive, and the 3's cancel, give me 2. And then I'm subtracting this 2. And that's all equal to 0. All right, this now becomes negative 8 over 9. Negative 8 over 9. Plus, this becomes 4b over 9. 4b over 9. This wipe out each other, and I'm left with 0. So basically, the b is equal to 2. But you can see that? The b equals 2, because the 9's cancel. If you multiply 2 by 9, you have a 0 here. And then the b equals 2. B equals 2. So now that b is equal to 2, now that b is equal to 2, we're going to divide. So the b is equal to 2 right here, but we're going to divide because I don't give a lot of space to work after 10 times. See? Not a lot of space. So we'll divide, right? Let's divide. So when we divide, we're dividing this by this factor. 3x plus 2 divided into this. So that is 3x cubed. The b is 2. So this is 2x squared minus 3x minus 2. So this divided by this give me an x squared. Then this times back these give me 3x cubed. And this time this is 2x squared. Subtract these gone, everything else are gone. So I'm left with minus 3x minus 2. So this divided by this give me back a negative 3. And negative 3, something wrong. Something is wrong. Huh? Something wrong. What did you get for your B? Huh? You get what? Anybody get 2? B for 2? You got 2? I'll check over your thing there. Maybe there's something wrong here, so. It's divided by that. It's x squared. X squared times that is 3x squared. X squared times that's 3. Oh, I make a mistake. Oh, yeah, this gone too. Minus 3. Oh, I see the mistake. I'm gonna see the mistake. Oh, I see the mistake now. It's a minus 6. This time this is a minus 6. Minus 6, okay. But something still wrong. I'm supposed to get 0. Something is wrong. Something is wrong. This first term divided by that. The cheese cancel, I get x squared. X squared times with 3x cubed. X squared times that with 2x squared. But b was 2. And the b is a positive 2. The b is a positive 2, right? Huh? Huh? Minus 1? Where? Where? Yeah.
You have this is 0 and this negative x divided by 3x. Would it be minus 4?
Wouldn't be minus, wouldn't be.
Yeah, because negative divided by 3.
No, hold on. Start over.
It's minus 1.
Hold on, I'm just want to make sure. Hold on. I'm not sure you're talking. So this divided by this is x squared, right? All right, let's just do it. X squared. Then x squared times these is something I make mistake, I just can't see it, you know. So I start over.
No, I just realized it.
All right, so it's 3x cubed. Then x squared times this is 2x squared.
Yes.
And I'm subtracting this.
Yes.
So everything is gone.
Yeah.
So I have minus 3x minus 2.
Negative 3x into 3.
This into give me, oh, minus 1. What did I have? Okay, all right, good. So this divided by this is minus 1. Thanks. Minus 1. Minus 1 times this is minus 3x minus 2. All right, thanks for that. I just wasn't seeing that. And I was at an event late last night. I didn't get much sleep, so kind of tired still. So you have to bear with me. All right, and then this time I factorize right traces. That's the difference of 2 squared, right? This becomes x minus 1, x plus 1. And so the 3 factors are these 3. All right, so f of x, we call it that, becomes 3x plus 2, x minus 1, x plus 1. Those are the 3 factors. Question done. All right. All right. That's it. I factorize it fully. That's it. All right. So let me tell you what I'm giving it to do now. Let me tell you what I'm giving it to do now. Watch this. Ready? Don't put it on a different, on a blank screen. I'm sorry. Ah, come on. Oh, this is in the way. All right, watch this now. Look at this question. Hey, pay attention now. I'm giving a graph of a function. It is f of x equals x cubed plus bx squared plus cx plus d. This point is -1. This point is 2. Find the value of b, c, and d. That's a function I gave you here. And I tell you that that's a curve of the function. This point is -1. This point is 2. And that's a minimum point right here. On the x-axis is 2. Find the value of b, c, and d. All right, let's start the clock again. I'm giving you, I really don't need more than 5 minutes to do this, you know. Let's start, 5 minutes. Find the value of B, C, and D. A very easy question. Super easy. You won't believe how easy it is. So you learn something from this question. If you don't yet know it. One minute, 40 seconds to go. I'll be shocked how easy this question is. Watch on header. Yeah, 50 seconds. All right, time up. All right, guys. So you're gonna learn something from these examples. There are some questions in maths that you learn stuff from. This is one of them. So remember how the factor theorem and the remainder theorem works. One thing in the factor theorem in particular is that if you know a root, you also know a factor. Stop talking now, stop talking now. Hey, stop talking. Never get the question. Just stop talking and listen. If you know a root, then you also know a factor. Roots are the x values where the graph intersect the x-axis. So these are actually roots. These are roots. So you know that one root is x equal -1. These are roots of the function. If you put this equal 0, then those will be roots of that equation. Roots are the points where the function crosses the x-axis. So if x equal -1 is a root, that means that x plus 1 is a factor of this expression. Now, the interesting thing about this point is that there are actually two roots there, just that they are equal. When there's a turning point on the x-axis, there are two roots there, two equal roots. So that point has two roots, two equal roots, right? Two equal roots. There are x equals 2 and x equals 2. So there are two factors there, x minus 2, x minus 2. It's called a repeated root. And so those are repeat factors. So these become the three factors of that function. So this function can be written as a product of these three things. This, and that. And then to get the A, the B, the C, and the D, you must have to expand it out. Get me? You understand that? So if you know the root, roots are the points where the graph intersects the x-axis. If you know the root, if x equals A is a root, then x minus A is a factor. X minus A is a factor. You have to remember that. If this is a root, then this is a factor. If you know a root, you know a factor. If you know a factor, you know a root. If A is a root, then x minus A is a factor. If x minus A is a factor, then A is a root. What's a root? A root on a graph is where the graph crosses the x-axis. And the next thing, the key thing to remember is that when there's a root, when there's a turning point on the x-axis, you have repeated roots there. There are actually two roots there. Can remember, you know, if this graph, if this x-axis was up here instead, a little bit higher, then you'd have three roots. It's just that it is positioned such that this minimum point is on it. So there's still two roots there, just that they are equal. And so this factorizes into the product of these three things. All right. So I'm going to say, therefore, the f of x that they gave us is the product of x plus 1, x minus 2, and x minus 2. Those are the three factors of the f of x that they gave us. So to find the b, the c, and d, you just have to expand this out and get the individual terms. So we can expand here first as a perfect square and do x plus 1 bracket. This other perfect square will be x squared minus 4x plus 4. If you expand this, then I'm going to multiply this across this now. So using the x first, x times each of these would be x cubed minus 4x squared plus 4x. And then the 1 times each of these. Put like terms under each other. So you're going to put this and this under here. So that will be x squared minus 4x plus 4. And they add them up to get the f of x. So f of x then is equal to x cubed alone that we had before. And this is minus 3x squared. Then this is 0, so you get 0x plus 4. So the b is negative 3 then. Or the b is the x squared coefficient, right? The c is the x coefficient, and the d is a constant. So the b equals negative 3, the b is c, the c equals this 0, and the d equals 4. That's it. That was a nice question. That's what you call a learn something from it question. Learn something from a question. Want another one?
Yes.
One said no. Come class with joke. You come class for work. I said no. Wrong answer. Wrong answer. Come do this one for me. Man said no to go. Man said no. You want another one. You don't come class to learn, my boss. You come class with joke. If you learn something for the first time, do one for yourself, man. Do one so that you get it. I'll give you a straightforward one. This is f of x. Huh? I'm giving you 3 clear points on this one. No repeat rule. 3 clear points. Huh? Because I can, no problem. Let this be minus 2. Make this be 2. And make this be 5. One said no, you don't want no more. Come, give me that sketch of that function. Crosses the x-axis at negative 2, 2, and 5. Find the values of b, c, and d. Find the values of b, c, and d. All right, come, 5 minutes for this one. You don't even need 5 minutes, but still, go on. We can get back to the past. Huh? Let's go over another short question. I'll give you 3 clear factors, 3 clear roots. We have 3 clear factors this time. Once you know the roots, you can know the factor. All right, we are going to about to teach anything new today because I'm really tired. It's a good thing. All right. All right, let's do this one. So the three roots are obvious. The roots. X equals 5 right here. X equals 2 right here. X equals minus 2 right here. And so from those two roots, we know the factors. The factors of this function. X minus 5 from this root. X minus 2 from this root. X plus 2 from this root. And so f of x can be expressed as a product of these three factors. Right? So f of x is a product of those three factors. X minus 5, x minus 2, x plus 2. That's the difference of two squares. So it then becomes x minus 5 times x squared minus 4. Difference of two squares right here. Then this now, x times each of these is x cubed minus 4x. Then minus 5 times each of these is, I put the minus 4x further down. Minus 4x. Then minus 5 times this is minus 5x squared. And minus 5 times minus 4 is positive 20. And you add up everything. X cubed alone. This is the only x squared term. It's the only x term plus 20. So the b is this value. The c is this value. And the d is that 20. That's it. All right. Want another sugar one? What time is it now? Huh? What? 6:40 what? Come, I'm going to sugar one to finish off. But sugar one is coming from my worksheet. Huh? Yeah. It easy still, you know. That's a sugar one, but it easy for true. All right, so this question is similar to what we just did. But they gave us those 3 points. Negative 2, 2, and 4. Similar question, this one, right? But this one I wanted to try. Right here. In the middle of the screen. There's a lot of algebra in it. A lot of algebra in this one. That one in the red, in the blue box. We're in 10 minutes to that one. 10 minutes, got a lot of parts. 10 minutes to do it. Huh? Can you see this? Come closer. There you go. 10 minutes. The quadratic that I gave you, it says, when it is divided by x minus 2, the remainder is r. When expression is divided by x plus 1, the remainder is also r. Find the value of b. When expression is divided by x minus 4, the remainder now is 2r. Find the value of c and the value of r. When the expression is divided by x minus t, the remainder is 5r. Find the two possible values of t. Come on, this is easy stuff. Come on, a lot of algebra. It's just a quadratic that they give you. Come on, let's go. I think we're going to finish off with this one. I look through my questions, I find any more sure question on the exam past papers that on these, I send it to the group. But exam past papers and polynomials tend to be like super easy, super easy. Oh, come on, do this one. This is just a lot of algebra, simultaneous equations and so on. That's what this one is about. Let me get ready to do it. All right. Let me, which paper is this? All right, let me do it here. So basically just plugging in the information that I give you in the factor theorem and the remainder theorem. That's what it is. And setting up equations based on information. So when this expression, so we're going to call it f of x. That's our expression we call it f of x. F of x is equal to x squared plus bx plus c. Let's say when divided by x minus 2, the remainder is r. It means that the remainder is equal to f of 2. When divided by x plus 1, the remainder is also r. So the same remainder is equal to f of negative 1. So the remainder is equal to f of 2, the remainder is equal to f of negative 1. These two parts can be worked out and give us an equation. Right? So I'm going to put these two parts together for now. I'm not worried about the R yet. F of 2 equals f of negative 1. Simple. What is f of 2? Plug 2 in here and here. F of 2 equals f of negative 1. So I'm going to get 2 squared right here, so it's 4. 2 right here, so times the b is 2b. Plus the c equal f of negative 1 now. Negative 1 in this. Negative 1 squared is 1. Negative 1 times b is negative b plus this c. The c is cancelled. C on each side cancel. This minus b goes over here and add to that 2b to give what? 3b. This 3 and this c cancel each other, right? Then this minus b comes on this side to add to that 2b to give me 3b. Then this 4 comes on this side and subtract from that 1 to give me negative 3. And so the b equals negative 1. That's the answer for the first part. Good? B equals negative 1. So now that b equals negative 1, we're closer to knowing the function. The function then is f of x equals x squared minus x, that is minus 1b, minus b, minus 1 times x is minus x, plus c. This is the function now, right? So we'll find the first part. Next part says when it is divided by x minus 4, the remainder now is 2r. The remainder is 2r. All right? I must find the value of c and r. So what we know now for part 2 is that f of 4 is equal to 2r. That's what they say. When divided by x minus 4, the remainder is 2r. F of 4 is equal to 2r. Now remember still, you know, f of 2 in the first part is equal to r, you know. And f of minus 1 in the first part also is equal to r, you know. See that? But we know the f of 4 is now equal to 2r. Good? So what is f of 4? We're going to plug 4 years and 4 years. So f of 4 becomes 60 minus 4 plus c equals 2r. 60 minus 4 is 12. 12 plus c equals 2r. That's one equation. Then we can do the f of 2 equals the r on this side. Or we can do the f of minus 1 equals the r, whichever one. Let's say we're doing the f of 2 equals the r. What's all we're going to get? Let's say we're using this one. We plug 2 years and 2 years, so we're going to get 4 minus 2 plus c equals r. That's what we're going to get. All right? And this reduces to 2 plus c equals r. So we now have these two equations solving simultaneously. See that? So to solve them simultaneously, we're going to subtract, right? Subtract. So it's going to be 12 minus 2 is 10. 12 minus 2 is 10. C minus C, the C gone. 2r minus r is r. So the r equals 10. So r equals 10. All right? They want to find the C now. No, so the r equals 10. We can plug the 10 right here. So we can say and 2 plus c is equal to 10. So the c equals 8. I could use right here, so I'm plug the thing right there. So 2 times 10 is 20. 20 minus 12 is 8. So that is it. The c is 8 and r is 10. So then we know function now becomes what now? Now that we know the c. Now that we know the c, f of x becomes, where is it again? Right here. C is 8. X squared minus x plus 8. What's it? That's f of x. So we know we also know the r is 10. What I'm saying yes or no? When it's divided by x minus t, the remainder now 5r. Last part 3. The remainder, otherwise is R. But this statement, so it said x minus t lead to a remainder, which is 5R. 5R is 50, you know, because R equals 10. Don't it? So that means that f of t is equal to 50. Simple like that. Because R is 10. And we're going 5R. 5 times R is 50. So this is the remainder from x minus t, f of t. F of t is 50. So I plug the t in this now and equate it to 50. So we're going to get t squared minus t plus 8 equals 50. Easy stuff. Carry over this and subtract it, we get negative 42. T squared minus t minus 42 equals 0. Factorize this. 6 times 7 is 42. That's all. T, 6 and 7 minus plus. That's all. 7, 6 and 42. Don't it? So t equals negative 6 or t equals 7. Those are the two possible values of t. So this question was really just an algebra question. I'm going to stop it here still for today because I'm really very tired. 7:02. All right. So Friday, I'll start the next topic, which is surds, logs, and indices. Surds, indices, and logs. The main part of that class will be the surds and the logs. All right. That is it. I'll send this recording to the group so you guys can redo some of those questions. All right. I'll see you all on Friday. Yeah, on Friday I'll tell you about Sun. On Friday we'll decide on Sun. But that is the aim. All right.